So I recently came across a video on YouTube, and it made the claim that one or one out of every three integers is even, or more specifically, 2/3 of all the integers are odd. So here's the basic rundown of what they did. We have our set of positive integers, z plus, which is 1, 2, 3, 4, 5, etc. And instead, let's take and write it as 1, 3, 2, 5, 7, 4, etc. 3, and of the 3, 2 are odd and 1 is even. So 2/3 of the integers are odd. But I think everybody has the intuitive understanding that that's not true, because the ratio of even integers to odd integers is actually e to the pi over 2. So we start at the same place. We start at z plus, which is 1, 2, 3. But this time, instead, our set is 2, 4, 6, 8. And we're going to have a 3. So with 2, 4, 6, 8, 3, we have a 4-to-1 ratio, or there are 4 evens for odds. But if we were to take, say, the first 48 and then have 10 odds, our ratio is 4.8, or 481 evens and then 100, we'd go to 4.81. And so we can repeat this, getting arbitrarily close to e to the pi over 2. So the question is, what is wrong with this proof? What's wrong with this? I don't want to say proof because it's not really a proof, but so the basic problem comes down to how we count infinity, or what is the cardinality of our set. So let's look back at that first example of 1, 3, 2, 4, or 5, 7, 4, etc. And we can break this down into 2 sets. 1, 3, 5, 7, and another set that is 2, 4. And both of these are going to go on. And now if we look at these sets without any gaps in them, right, it becomes fairly obvious that they are in fact the same size. And so what size is each of them? And the concept is something called either denumerable, or it's also called countably infinite. And so the problem here comes from the different sizes of infinity. So in a way, the proof that I was on YouTube earlier has 2 and then 1, and then 2 and then 1, and both repeat infinity times. But 2 times infinity is the same size as infinity, and infinity is the same size as infinity. That's not to say that 2 times infinity is infinity, because you get into the argument that infinity is not actually a number. So if we want to talk about what infinity is, and I'll only go into this briefly. Infinity is the idea of ever increasing. So if you look at something simple like x squared, we say that it goes off towards infinity, or it diverges to infinity, not it is infinity. Because for any real number that we put into f of x equals x squared, we are going to get an output. But what happens is every time we put in a bigger number, we get out a bigger number. And at no point does this stop. So for every n plus 1, it's greater than n. And since there are unlimited integers, they all get bigger. We're heading off towards infinity. And so the next question is, if our sets here are countably infinite, is there a bigger infinity? And the answer to that is yes, but I will cover that next time.